So today we're going to be doing Leetcode 2816, double a number represented as a linked list. You're given the head of a non-empty linked list representing a non-negative integer without leading zeros. Return the head of the linked list after doubling it. So it's a pretty simple problem. All you gotta do is just add up the numbers um, from the linked list. So we're gonna first create the number. First step is we're gonna be creating the number using whatever numbers in the linked list, and then we're going to be doubling it, and then after we double it, we're going to create the new linked list. And yeah, so it's basically a two-step process, uh, and it's, I guess, require two pass in a sense. Um, and one thing that we have to, I guess, worry about this problem is the creating the linked list after getting the sum. So let's just say we have this number 9, 9, 9. So what we're going to do is we're going to iterate through this linked list. And since it's not given to us in the backwards fashion where we can, just get the number easily, uh, in terms of like adding it up or doubling it, we have to go through it one by one. So 9, we get 9, we multiply this by 10, and then we go here, we get 90, we add plus 9, we get 99, add multiply by 10 again, then we go here, we get 990 plus 9, and we'll get 999. So essentially we'll be iterating through each node of the linked list, and then what we'll be doing is for every single node we'll be adding it to a variable. We'll be adding the value to a variable and then multiplying it by 10. So that way we have every number within its correct place, such as if it's in the hundreds, tens, or thousands, right? So we have 999. We've made 999 using this linked list, and all we're gonna do is now is just double it. So we'll get 1998. Now here's where the hard part comes in. So you can do this two ways. One way is make this number into a string. And then once we make it into a string, we can then make it into a linked list. But if we do that, that's kind of, I guess, cheating, or I guess that's a very Pythonic way of doing it. Other languages are not so pleasant and as easygoing for doing stuff like this. So we're gonna do it the way where everyone's able to do it, which is we're going to, every single iteration, we're gonna pop off one digit from the end. So first iteration, we're gonna pop off 8. Second iteration, we're gonna pop off 9. Third iteration, we're gonna pop off 9. Last iteration, we're gonna pop off 1. So now, and then every time we pop off, we're gonna create a node using this. And we're going to then add it to a linked list. Now you can add this to a linked list in two ways. One way you can do it is where as you're going through and popping off each digit, and you're making a node for each linked list, linked list node, what you can do is you can have a dummy node. So dummy node, and then what you can do is just point to the new node, right? So 8, and then once you go to the next iteration, instead of appending it to the end, which is I guess the intuitive part, instead of appending to the end, what you can do is just take that new node that you made with this 9 and just insert it in here. So then you would have dummy 9 and then 8, and then repeat the process. Just insert it right after the dummy. Then you get 9, 9, 8, and then once again 9 and dummy here. So that's what you can have, and then you would just return dummy.next as your answer. And another way to do it is, so you create the head using this 8 node, and then you just keep appending. So 9, 9, 1. So now there's an issue here, which is obviously we have our answer backwards. And one way to go about this is just by reversing it. And the way we'd reverse it is simple. You know, a simple linked list node reverse. So all we would do is every iteration we would hold. So let me just create this list. We would hold the reference to the rest of the list, and then what we would do is we'd take this current node that we're on and we'll flip its orientation. So now we'll make it look like this, and it will be pointing to none. And we'll obviously have a previous variable pointing to nothing at first, but then we'll move our, so we'll have 3 variables. We'll have prev, cur, and next. So we'll move our current node and our next node and our prev node, and prev will start off at none, current will start off at 8, and next will start off at the next node of current. And essentially it'll be the variable that we holding down the rest of the list for us, so we don't lose it and we have no reference to it, right? So we'll flip the orientation. Now the list will look something like this: 9, 9, 1. So now we still have our current prev here. We still have our current here. And we still have our next here. Right? Now all we do is just move everything over 1. So we have our next. We're holding it down we're holding it down, and all we just gotta do is just set it equal. So now cur will be here, and then also we'll move. You can use a temporary variable or whatever, or you can set it before you move cur, but we'll move our prev to here. And then again, we want to, before we change the orientation of this current node, we're going to move our next. So we're going to move our next here. And then we're going to flip the orientation. Or we're going to flip the current node we're at based on this graph. So 8, 9, and 1. And our prev is here, current is here, and next is here. And then if we continue to repeat the process over and over again, at the end we should only exit this iteration once current is a none node, as in we have nothing to flip or nothing to change orientation, and our prev will be actually pointing to the end of the list. And I'll just, I guess, quickly draw it out. So we'll have this 8, 9, 9, 1, and then we'll return prev. So yeah, these are two ways you can solve this problem. You can either use the dummy node method, or you can use this reverse linked list method. Both of them are O of n. You're not really going anything above linear, and yeah, your space complexity will also be O of 1 if you're not counting, or if you're not counting the return answer, or the output answer as space. We're not really using any space besides a couple of integer variables. And yeah, for the solution, the written solution, I'll be doing the reversed linked list, just because it is the harder of the two, and appending to the front of a node isn't that difficult. So I'm going to be doing the reversed linked list solution. So yeah, we are going to start off by doubling the number. We gotta know where we're exactly doubling and what we're exactly creating the linked list from. So this is what I'm gonna do. And then head.next. Now I'm gonna do a division operation here, just because we are going to be multiplying by 10 one extra time than we should. And then going to be multiplying, and this should give us our answer, and then we're going to be multiplying by 2 to get our answer. We're going to make a new head for the new linked list, and we're going to set the first value. So then, and then we're going to divide by 10 again, because we've just popped off a digit and we want to make sure everything is kept account. So now we should have one less digit, and now we're going to go into we're going to make a pointer variable, and we're going to keep doing this till our number is 0, as in we don't have any more digits to pop off. So we're going to do list node num mod 10, and then we're going to move our pointer to the next available spot where we can add in that node. And obviously we're going to also have to adjust our number so it shows that we've popped off a digit. And then finally we're going to reverse it, right? So I'm going to create a function to reverse it, pass in a head, and I'm going to write next one is equal to none. I'm just going to set it to none for now. It doesn't matter what next starts as before the loop, but what does matter is prev starting as none, because we want to make the head of the head of the node point to none, because remember that's how we flip our orientation of the head from pointing to an actual node to pointing to none. So prev, and then cur head. So now we made our pointer variable, and now that we made our pointer variable, we're just gonna iterate through. So remember, we need to have a reference to the rest of the list, so we're gonna do cur.next into next one, and then cur.next, we're going to flip, this is where we're going to flip the orientation. So now we're going to make the current node that we're at point to whatever was previous, and right now at the beginning previous is none, but obviously it gets updated. But yeah, and then once we flip that orientation, Now we know that the current node we're on is going to be the new previous for the next one, or the next node that's at next one. So previous cur, and then we're going to do current is equal to next one, and we're doing that because we have to move our pointer, and we're going to be now shifting the orientation of the node at next one for the next iteration. And then at the end, remember, we are running this loop till current is none. So that means the last node, or the head of the new linked list, will be at prev, or be in prev, and we return prev. Now let's run that. Okay, my bad, forgot to return verse head. Now let's run that. Okay, good. And yeah, as you can see, we passed. So yeah, thank you for watching, and see you next time.